program we have. We have two body programs. The first is called the SafeGamer program. That is, you build any kind of a gaming application utilizing some very simple application interfaces of our SDK. You get a chance to win $1,500. And we also have a seed builder program, which is like incredibly popular from our last experience, because for that you can just use any Celer SDK functionality, build any kind of application, and the first two people registered with us will be able to split the $1,000 award in total. So that's like we found out that's a really incredible program, and if you just want to spend like 2 or 3 hours try it out, you can. So just before we formally start, I just want to say that this is going to be the last time, probably the one of the last times that we kind of talk through the raw level of the API of Celer. In the future, we're not only going to talk about the raw level of the API, but also going to start to talk more about the application-facing stuff. That is, if you're just, for example, building a game that is focusing only on this kind of HTML5 game, we will have some very, very simple wrapping API around that. But that part is still being cooked right now, and we are going to have our mainnet launch next month. And in fact, we just had our private mainnet launch at our booth. So whatever the software you downloaded at our booth is actually running on mainnet today. It's just like nobody knows about that yet. So you guys kind of get the exclusive access, early access to this. So without further ado, I will pass the mic to Michael, and we'll just talk about the current SDK stack we have. We currently have 3 kinds of SDK, but they all share relatively similar kind of interfaces. One is the web SDK, the other is two systems, like a native mobile SDK of Android and iOS. So this is like a very intimate environment, so feel free to stop us at any moment and ask any questions. All right, we can start.
All right. Hey, everyone. I'm Michael from Celer Network. And today I'm going to just briefly go through our current setup of our SDKs. Just a brief introduction of Celer is we're this state channel, generalized state channel network that supports both payments and generalized DApps, which could be highly interactive and scalable. And some examples of the past projects we've seen at other hackathons are, for example, this is a prediction market. So basically, we use Chainlink as an on-chain oracle, and then clients will send conditional payment based on the oracle results from on-chain. So if some conditions is met, Alice is going to send a payment to Bob, and that.
So this is the part that it's a little bit different from, let's say, Lightning Network or any other just simple off-chain payment design. That is, you have the kind of native capability to send a payment off-chain, but that is conditionally depending on some other conditions. And that condition can be an on-chain contract, and also can be an off-chain state channel contract that is finally resolvable on-chain. Right? So that's kind of like the construct. You send out the conditional payment. You can think that conditional payment is wrapped with a contract address, and that contract address has some function pointer towards that contract's certain functions. We have kind of a expected interface towards the dependency contract. So that's kind of roughly how it works under the hood. But in terms of the API cost, you can look at the doc, and we can definitely help you walk through that.
Right. And this is another example where I think it's a very good use case of micropayments. So you have a cloud provider that provides some kind of SLA guarantee for service. And if, say, the provider violates the SLA terms and the service is down, then you notice that, and the provider is going to send you a micropayment as a compensation. So this is another use case of how powerful the Celer's conditional payment framework is. And I think this code is on GitHub, and you can check it out and see how it calls the Celer APIs. And so how many of you are web developers or any mobile developer for? Okay, cool. So we actually have SDKs for web, Android, and iOS. And I'm gonna just go through the APIs of the Web SDK because that's probably the easiest one to demo. Let's see. So here we have. Sorry. Okay, so if you go to celer-network.github.io, and that's where all like our documents are. And so I'll just go through a simple demo here. Sorry. And if you go to github.com/Celer Network and search for the Celer Web SDK, and under demo there's a very basic demo of how you like set up a Celer client and open a state channel and send a like payment of one way to the counterparty. So that's like it's a micro payment, right? So if you were to send this on chain, you're gonna cost like more gas than the actual payment. But in this case, you can like send one way free and instantly. And to run this, you have to we provide a pre-built Celer client binaries for both Mac and Linux. And you just go to github.com, Celer Network, Celer client, and you check out the repo and you follow the README. So this is gonna start a local Celer node. So it's gonna connect to the Celer network service providers, and basically it routes the payments for you.
But if you're using mobile, this step is definitely not needed.
Right. If you're using mobile, it's not needed.
Yeah, that's
right.
wrapped in the mobile.
So the mobile SDK has the Celer client embedded, and you don't need to like. So this is for like web and desktop. And let's see, I can zoom this. Okay, I guess I can zoom this. I can use raw. Okay. So this is on npm, and you can like npm install this package celer-web-sdk. And so basically, you do like a new Celer client, and this is the endpoint to your local Celer node. And you do like client open channel, and it's a promise. And once it resolves, it gives you channel ID, and which isn't quite useful in this case, but you can verify it on chain. And then you can get the balance of the client, and it will print the balance in the console. And you do like send ETH, which sends an off-chain like off-chain unconditional payment of one way to the destination. And you wait a second, and then you check the balance, and the balance should be updated. So I tried to run this before, but it seems like I got some like error, which I'll figure out like very soon, guarantee. So yeah, that's a very simple like basic payments. And for like more complicated stuff, where if you want to build something like the Gomoku game we have, you're gonna look at more APIs. So basically, you can create an app session that has the like virtual contract, the information of the virtual Gomoku contract. And then you can send a payment based on the condition of the Gomoku contract.
So maybe at this point, let me just like inject here and talk about the concept of virtual contract or like state channel contract. So how many of you actually heard about like generalized state channel, the general concept? Okay, all right. So the concept of generalized state channel is this. It's basically you have some program and that involves certain defined party. Let's say there are like 3 defined parties involved in this game, 4, 6, 10, but it's limited number. It's not infinite number. Now, the concept of state channel is so that each, basically for each state transition of this application, we don't actually need to broadcast a blockchain transaction to the entire network. We only need to reach consensus among these 10 people, as long as we get all the signatures from all the 10 people on a serialized state of this application. Basically, let's say the application has some internal parameters, internal data structures, and all that stuff. But all that stuff can be serialized into some data structure, right? So let's say in the very concrete case of Gomoku, you can serialize that entire data structure into a byte array, right? So some like a protobuf format. So we actually recommend protobuf here to do this kind of data structure serialization, as we do have this kind of an in-house protobuf parser built, and that is also open source available on Solidity. So you get this newest app state, and the idea is that you basically add your signature on it, and you send to your counterparty. And your counterparty will receive the state update, look at state update, and figure out whether this state update you're proposing is actually a valid state update. If this is actually valid state update, the counterparty send back that state update basically. Now this entire process is kind of the state progression of a state channel application. Right, so you basically kind of do this kind of entire state progression little by little, and the interesting part here is that now where does that actual game or a chessboard game or a phone game actually live? Well, in the cooperative case, you don't actually need to instantiate any smart contract on the blockchain, because you only need to kind of agree on, okay, this is a code that we are going to run if we deploy the stuff on the blockchain, right? So, basically, let's say we agree on the bytecode of the program, we agree on the parameter of the bytecode, we agree on the input or a random nonce that is kind of marking, kind of deduplicating any kind of ambiguity of our agreement, because we may want to play multi-session of the game. So, we agree on these things, and we hash all the stuff together and generate something called a virtual address. Okay? So Ethereum recently introduced something called the Creator 2 that kind of let us escape that process. That is available in our next version of the release, but not right now. Right now, we still use the concept of this virtual address. Now you have this virtual address. What it means is that once you actually want to do some resolution, let's say one of your party dropped offline in the process of playing the game with you. Now you get into a situation where you are halfway through the game, you have some conditional off-chain payment that is depending on the game result. Right? So the dependency though is established through the conditional payment call, like send conditional payment call. And now what you want to do is you actually need to deploy the contract on the blockchain and then revert the process doing the on-chain transaction and stuff like that. But most of them for the short time of the hackathon, we probably don't you guys probably may not have the time to do this kind of entire flow transition. But I just want to talk about this process so we know I can share that how generally a state channel is progressing the internal state, and also in terms of how the distributed resolution or how the state educator is actually working, right? So now the app, the virtual address that I talked about is generated through the call of a create app session. If you see that part about, yeah, create app session, and there are some app info in it, and that is kind of where we stuff all the garbage of the contract code and all that stuff into that. You stuff the API, you stuff the binary, you stuff the constructor parameter, you stuff the nonce. That's kind of the app info, right? So, and once you have that app session created, now what you can do is you can kind of send a conditional payment, send ETH or send ERC20 with condition on it. There is a specific destination, specific string, and specific condition. And if you click into that condition, what the condition really is talking about effectively the first thing is what is the dependency, right? So the address is basically a mark or identifier of the dependency. So you basically pass that part in, and there are also some other things that is needed for this particular case of conditional payment. That is, you want to check whether the off-chain process is actually finalized or not. And in most of the cases, it will actually be finalized. And in normal cases, it will be totally finalized. And the query result will get you what is the result of the game. And in the case of a simple Boolean condition, the query result is basically just going to return Boolean. You basically pay out the money, and if you win the chess, the money you conditional pay out get the result to false. but the other way can resolve the truth, basically.
Is it just a callback, or do we have actually query?
So, this stuff is the parameters that you pass into the to the SDK, but SDK handles that for you. So when the progression of the state finally resolves, you just call resolve condition rule, and all this stuff will automatically get resolved for you. So if no worries, we'll go through these APIs, just come to our developer or ask questions in Discord, we'll help you out basically.
Right.
Walk you through the process.
So in the case of like a deploy, so if you basically if Alice and Bob's goes into dispute, right, and say the Gomoku contract is actually deployed on chain, in that case, we require that the contract implements two methods, is finalized in query results. And in that case, the SDK handles how basically queries on chain to see if the condition is finalized. So basically it transitions from a virtual contract to an actual deploy contract, and the interfaces still remain the same.
Yeah, but in most of the cases, this thing won't trigger, and probably in the development process of this hackathon, we probably don't need to go into that the transition part yet. Just want to get a general understanding of the SDK. Even for simple payments, it's also a good use case. Yeah.
Yep.
Okay. So maybe you can.
So yeah, and we also provide if you want to do interactive games. Last time, someone did let me show.
It's a pretty fun game.
Yeah, let's just go back to the page. Interactive game.
So you can find it, the newest one on YouTube channel, in our YouTube channel.
Yeah. Let's see. So yeah, last time at East Denver, right? Someone did say, for example, this one. It's a rock paper scissors kind of game. So it's called Bulls, Bears, and Buffetcorns.
Oh, just like stone, scissors, something like that? Yeah. Oh, cool.
That's my voice, unfortunately.
Embarrassing.
Yeah, and also on the mobile side.
You lose some money?
Yeah. And it could be a draw as well, so we choose ball as a draw if nothing happens.
Great.
Yeah.
Excellent.
Yeah.
Thanks a lot.
So also on the mobile stack, we also have one example.
We have
you can refer to the East Denver's repo. They probably all have that there.
Yeah.
You just click into the.
Yeah, there's a battle bomber. Right?
Yeah,
that's the one.
This one. Yes.
Yeah, this one. Let's see.
All right, cool. So what I'm going to do is I have my wallet as an app, and I want to create a game against one of my friends. So in iMessage, we have an extension where I can instantiate a new game. What this is going to do is this is going to create a new Celer client and also create a game and send an invite. So the game concept is I need to place 4 bombs. Okay. Now this is all packaged up. So in that package is also the Celer game ID and my current game state. So when I send that to one of my friends, he's going to receive a message on his side.
I'll have to change that. So this is the message.
So now he gets 3 tries to try not to blow up. If he blows up, he loses. 1, 2. He won! So now the game is complete. The stake between the 2 wallets using Celer can now transact. And everybody gets paid and has fun.
Yeah, so that's pretty much it. It's basically I think they used this. Let me show you. This send state API which we have in the current version of this SDK, but in the future we're going to decouple this from the SDK, so you can like send states via like any other form. Like you can upload to say IPFS, and then the counterparty can download it, and but the state machine can still progress. So basically, we provide this framework to like handle the state progression for you, and like more on that later. So yeah. So feel free to like catch me at question.
How could this possibly, or how could we integrate with Thundercore? Is there a viability when it's EVM compatible?
Yeah, that's a good question, because we're like, well, I think the prerequisite is for us to say like deploy the Celer state channel contract on Thundercore, and then so that's like a prerequisite. But since they're EVM compatible, I think that should be a like pretty easy task. And yeah, if I have some time, I can look into that and see how easy it is. What's that?
We can catch up afterwards, I guess.
Yeah, definitely. Yeah. Yeah. So yeah, definitely. So like if you have just like try to like run the demo. It won't work for now. I'm just gonna fix the server side for some, like for some reason it was like getting me context deadline exceeded, but I'll fix that, and then like you can try to run the demo. And there's another like let me show you. There is a slightly more complicated demo with send and receive. So in this one, you can basically client 1 sends to client 2, and I believe client 2 also sends back to client 1. So you have like two people send to each other. And yeah.
Yeah, I mean, you know, on any other blockchain, as long as EVM compatible, can support layer 2 construction.
Yeah. I mean, technically, as long as the blockchain is like supports some kind of like Turing complete smart contract logic, we can implement a Celer contract, and then yeah, we're doing that for like some other blockchains as well.
All right, so let's catch up afterwards.
Yeah, sure.
All right.
All right. Any questions? Any stuff that can help? I mean, we're going to be right there. Like, right
Yeah, we're right there. So yeah,
we got some cool unicorn t-shirt. All of you guys are very welcome to, after this talk, get one of these unicorn t-shirts and some of the cool stickers we have. Yeah.
And we have a lot of amazing prices, like the Nintendo Switch or Bose soundbar. If you're interested, definitely check it out.
Yeah, so you know we have that you know the Gomoko game. We have something called King of Gomoko. So if you're like tired of coding or anything, just like play some game, and you know maybe you get top on the leaderboard, and you know at the end of the day we've got like a Switch back or some kind of stuff. Cool.
all right.
Awesome. Thanks.
Thank you.
Well,
Thank
yep.
you for coming.